This video will go over section 7.6 on Dalton's law and partial pressures. Dalton's law says that the total pressure, P total, of a gas mixture is the sum of the partial pressures of its component gases. So let's say you have a mixture of three gases, A, B, and C. To find the total pressure of the mixture, you will take the partial pressure of A plus the partial pressure of B plus the partial pressure of C. As many times as you have gases, you will add those partial pressure to obtain the total pressure. So what is a partial pressure? The partial pressure of a gas is the pressure that each gas in a mixture would exert if it were by itself in the container. So let's look at an example here. If you use a gas tank of a given size and you place some helium in there at a pressure of 2 atmospheres, so that's the left gas tank here, showing partial pressure of helium of 2 atmospheres. Let's say you take another gas tank of the same size and you put argon in it at a partial pressure of 4 atmospheres. Now, if you mix those two gases, helium and argon, into a same size of gas tank, and you mix them, you will get a total pressure that will be equal to the partial pressure of helium plus the partial pressure of argon. And so partial pressure of helium is 2 atmospheres, partial pressure of argon is 4. So 2 plus 4 is 6 atmospheres for the total pressure. So this illustrates how the partial pressure of a gas is the pressure that the gas would occupy if it were by itself. So let's see how we can use this gas law by going through this example. A sample of exhaled air contains 4 gases with the following partial pressures. Nitrogen has at a pressure of 563 millimeters of mercury, oxygen at a pressure of 118 millimeters of mercury, carbon dioxide at 30 millimeters of mercury, and water at 50 millimeters of mercury. So the question is, what is the total pressure of the sample? So if we use Dalton's law and the law of partial pressure, we know that the total pressure is equal to the partial pressure of nitrogen plus the partial pressure of oxygen plus the partial pressure of CO2 plus the partial pressure of water. Then you just plug in the values for the different partial pressures. So in your calculator, you add them. So 563 plus 118 plus 30 and plus 50. And the calculator answer is 761. And because all gases were at the same unit of millimeters of mercury, the total pressure will also be at a unit of millimeters of mercury. So here, I should have said this beforehand, but it makes sense here that we can add those partial pressures because they are all in the same unit. You cannot add partial pressures that are at different units. They have to be all in the same unit. And then the total pressure will take on the unit of the different partial pressures. So let's do a learning check here, and you can pause the video and work this out on your own before you watch the answer. So it is about air, and air, you know, it's this layer of gas that surrounds the surface of Earth, and we call it the atmosphere. And so the atmosphere at the level of, you know, Earth's surface, we call it air. And it's mainly made of oxygen and nitrogen. 80% of nitrogen, 20% of oxygen. There are many other gases, but that's the main 2 gases in air. And its percentages by volume. So what is the partial pressure of each gas at sea level, where the total pressure is 760 millimeters of mercury? 760 millimeters of mercury, you know that it's 1 atmosphere, and that's, you know, the standard pressure at room temperature at sea level. So here we know that the total pressure will be equal to the partial pressure of oxygen plus the partial pressure of nitrogen. We know that the partial pressure of oxygen is 20% of the total pressure, right? Because the mixture is made of 20% of oxygen. So you take 20% of the total pressure, and that's going to give you the partial pressure of oxygen. Same thing with nitrogen. You take 80% of the total pressure, and you will get the partial pressure of nitrogen. We are given the value for the total pressure. It's 760 millimeters of mercury at sea level. So then we need to just use that to calculate the partial pressures of oxygen and nitrogen. So oxygen first, it's 20% of the total pressure. So the 20%, when you use percentages in calculations, you always want to divide the percentage by 100. And so that's the percentage in decimal form now, 0.20, right? You multiply that by the total pressure of 760 millimeters of mercury. And the calculator answer is 152. Here, because 20% has two significant figures, 760 millimeters of mercury, also two sig figs. So we will round to 150 millimeters of mercury to account for the number of sig figs. Let's calculate the partial pressure of nitrogen. It's 80% of the total pressure. So 80% divided by 100 is 0.80. So it's the percentage changing it into a decimal. So 0.80 times the total pressure is 760 millimeters of mercury. When you do this together, the calculator answer is 608 millimeters of mercury. So again, to take into account the number of sig figs, which is 2 in 80% and 760 millimeters of mercury. So this 608 rounded to 2 sig figs will be 610 millimeters of mercury. So there we go. We have our partial pressure for each gas at sea level. You may want to check your answer by adding those two partial pressure and check that you get back your total pressure. So you add the partial pressure of oxygen, 150 millimeters of mercury, plus the partial pressure of nitrogen, 610 millimeters of mercury. And when you add that, it's indeed 760 millimeters of mercury, which is the value of the total pressure for air.